Okay guys, so in this video we are going to address what happens when we have a elements like roots and we have variables in the denominator when we want to differentiate a function. Um, so far we have only learned to differentiate a function through this rule. Remember, if the function is like this, then the derivative is dropping down the exponent to multiply whatever is here and subtracting 1 to the exponent. But that works for terms of polynomial functions, and when we have roots and the variables in the denominator, those are not polynomials. However, we can transform them to polynomials in order to apply the power rule. Um, how are we going to do that? We are going to do that by the use of two specific properties of exponents, which are as follow. For example, when we have something like this, yeah, something to a given exponent, but in the denominator, it is just this, the negative exponent. So let me give you a couple of examples. Let's say that we have 3 to the power negative 2. That would be, sorry, give me a second, I erase, 1 over 3 to the power 2. It's basically just dropping down this to the denominator, um, but with a positive exponent. Or if we were to do the opposite, putting it up with a negative exponent. Let me give you some examples with variables. For example, we have 3x to the power negative 2. That would be 3, but we drop down the variable to the denominator, to the power 2. And coming from here to here is what we're going to do when we have to deal with a variable in the denominator. Also, when we have roots, we can rewrite this expression as a fractional exponent. Look, whatever exponent that was here is a 2, is in the numerator, and whatever exponent was here goes to the denominator, and then we got rid of the roots. So let me give you a couple of examples. For example, the most basic one, 3 square root of 3, let's say. So what number is here and what number is here? Remember that if you don't see the exponent, it is supposed to be a 1, but in roots, if you don't see anything here in the index, it's supposed to be a root because it's a square root. So that will allow us to rewrite this as 3 to the power 1 half. And the same happens with variables. Let's say that we are going to have this fifth root of x to the power 2. That will become x to the power 2/5. So these two properties are the ones that we are going to apply whenever we have denominators with variables and roots. That will let us transform it to exponents, and then we will be able to differentiate. So let's work a couple of examples. Let's say that I'm working with f of x, and in this time we are going to do this 3 square root of x to the power 3 minus 2 time over 2, sorry, not 2 because that will cancel, 3 times x to the power 4. Okay, let's make it a single fraction. Then, before differentiating, we are going to transform the function. So that is why I'm not putting the apostrophe yet, because we are not differentiating right now. Let's just transform. This will become, remember, if there's nothing in the index, it's supposed to be a 2. So this will become x to the power 3 halves minus, and now, remember, if the variable is in the denominator, we can move it upwards, but with a negative exponent. So that will be 2x to the power negative 4 over 3. Okay, remember that it's the same to write this, negative 2x to the power negative 4 over 3, or negative 2/3 of x to the power negative 4. It's exactly the same, so don't worry. After when differentiating, we move this to multiply the 2/3 and that's it. Or we move this to multiply the 2 and then divide by 3. Whatever, it doesn't matter, we will get to the same result. Now that we have an expression with not roots or variables in the denominator, then we can differentiate. Now I am going to put the apostrophe because now we are differentiating. And let's remember the power rule. Move the exponent to multiply. So it's 3 halves times x, and subtract 1 to the exponent. 3 halves minus 1 minus. Okay, let's move this negative 4 to multiply this 2. So it's negative 4 times 2x, and negative 4 minus 1. We subtract always 1 to the exponent. And we leave the 3 in the denominator. Let's simplify it. It's 3 halves. And 3 halves minus 1 is just 1/2. Minus negative 4 times 2 is a negative 8. X to the power negative 5, because negative 4 minus 1 is negative 5. And here. But we can simplify this even more. This is already the derivative, but that is not enough to get a proper answer. Okay, we need to simplify as much as possible, and once again get rid of the negative exponents and the fractional exponent. So we are going to actually use the properties that we have already discussed to turn them back into variables in the denominator and roots. For example, here, let's transform this into a root. So it's 3 halves of x. So here's a 1, here's a 2, but this 1 is not necessary to write, and this 2 is not necessary neither. Okay, negative and negative here, that becomes a positive. 8x to the power negative 5 over 3. But again, we don't like that in our final answer, so we are actually going to drop it down with a positive exponent, basically doing the opposite of what we have done before. And let me do it. That will become x to the power 5 in the denominator, and that will be it. Okay, so basically that's how we deal with those cases.